Hello friends, let's continue to evaluate limits, right? So if you have a problem like this and you want to evaluate this limit, how can you do it? Um, Now, if you look at the first problem, the the limit is as x approaches -3, right? So if you plug in -3 into that expression, observe that if you plug in -3 into the denominator, which is x squared minus 9, you are going to get 9 minus 9. So the denominator is going to be 0. 9 minus 9 is 0, right? And we want to avoid that. So how can we evaluate this limit? The way we can evaluate this limit is that observe that the numerator, right, x squared plus x minus 6, we can factor that. We can factor that. And if you factor the numerator, you want to look for two numbers that when you multiply them, you get -6. And when you add them, you get, when you multiply them, you get -6. But when you add them, you get 1, which is the coefficient of x here, right? So, and those two numbers are going to be 3 and -2. So if you simplify the numerator, right, you are going to get x plus 3 and x minus 2. So if you factor, so you have, this is going to be x squared minus 9. Okay, so now for the denominator, I can instead of writing 9, I can write 9 as what? 3 square, right? And recall difference of squares. If you have something square minus something square, what is that going to be? So let me write the denominator first. This is going to be x minus 3, x 3. This is by difference of squares. So x squared minus 3 squared is equal to x minus 3, x plus 3. So now let me write the numerator, which is x plus 3, x minus 2. So this is limits as x approaches -3, right? So now what I can do is that I can observe that x minus 3 can cancel out x minus 3, right? So I'm going to be left with what? I'm going to be left with x minus 2 in the numerator and x minus 3 in the denominator. So as this as limit, this as x approaches -3. So now I can plug in -3 into the expression, into this expression here. So I can plug in -3. So I have -3, -2 over -3, -3. This is going to be -5 over -6. And this is just 5 over 6 because this is going to cancel out. So that's the limit for that. So I hope this helps. Now let's look at this other one, right? The limit of that complex looking expression, right? The limit of that complex looking expression, this one here, as x approaches infinity. So now when you have a limit like this, how do you find limits like this? Now the way you find the limits like this is that you look at the denominator, right? You look at the denominator, which is 3x to the power of 4 plus 6x cubed minus 7. And you look at what's the highest power of x there. The highest power of x there is x to the power of 4. So what you are going to do is that you are going to divide each term in the denominator and in the numerator by the highest power of x in the denominator. So let me just write that. So this is going to be limit as x approaches infinity of so I have 4x cubed divided by x to the power of 4, right? Because x to the power of 4 is the highest power of x in the denominator. So plus 5x divided by x to the power of 4 minus 2 divided by x to the power of 4. So everything divided by 3x to the power of 4 divided by x to the power of 4 minus 6x cubed divided by x to the power of 4 minus 7 divided by x to the power of 4, right? And using the rule of exponents, if I simplify each of those terms, right, the rule of exponent that says x to the power of n divided by x to the power of m, this is going to be x to the power of n minus m, right? So using that rule, if I simplify each of those expression, each of those term in that expression, so I'm going to get what? So for the first term, which is this term, what am I going to get? I'm going to get 4 divided by x, right? Plus for this next term, right, which is 5x divided by x to the power of 4, I'm going to get 5 divided by x to the power of 3 minus 2 divided by x to the power of 4. Everything divided by, for this term, the denominator, I'm just going to get 3. And then for this one, I'm going to get 6 divided by x. And for the last term, I'm going to get 7 divided by x to the power of 4. Okay? And then this is just going to be, now if you plug in, so I don't know if you know this, but if you have a number divided by infinity is equal to 0, a number divided by infinity is equal to 0. So technically, if you take the limit as x approaches 0, technically, if you plug in infinity, normally you don't plug in infinity, but just so that you understand, I'm going to just plug in infinity. I don't really think it's mathematically correct, but just for you to understand, this is going to be 5 divided by uh, infinity cube. Infinity cube is just infinity, right? So 2 divided by infinity, because infinity, if you plug in infinity to this term here, right, it's kind of like infinity to the power of 4. This is just also going to be infinity. So this is just going to be divided by 3 minus 6 divided by infinity minus 7 divided by infinity. And just like I said, 4 divided by infinity is going to be 0. So this is also going to be 0. This is going to be 0 divided by 3 minus 0 minus 0 is 0 divided by 3. This is just going to be 0. So your answer there is 0. Okay, now let's do the last problem, right? We are still going to apply the same approach. Now look at the denominator. Look at the denominator. What is the highest power of x there? The highest power of x there is going to be x to the power of 3, right? So I'm going to divide each term in the numerator and in the denominator by x to the power of 3. So I have, this is going to be limit as x approaches infinity, x to the power of 3 divided by x to the power of 3 minus 5x divided by x to the power of 3 minus 2x divided by x to the power of 3, everything divided by 3x to the power of 3 divided by x to the power of 3 minus 6x squared divided by x to the power of 3 minus 7 divided by x to the power of 3. Okay, so let me simplify this. So this is just going to be limit as x approaches infinity of x to the power of 3 divided by x to the power of 3. This is just going to be 1 minus 5x divided by x to the power of 3 is just going to be 5 divided by x squared. Then I have 2 divided by x cubed. Everything divided by, for the denominator, 3x cubed divided by x cubed is just going to be 3 minus 6 divided by x minus 7 divided by x cubed. And now, if you plug in infinity, you're going to have 1 minus 5 divided by infinity, 2 divided by infinity, 3 minus 6 divided by infinity, 7 divided by infinity. Okay, and this is just going to be 1 minus 0, minus 0, 3 minus 0, minus 0, and this is just going to be 1 over 3. And that's it. So I hope, this helps you understand, how to evaluate, how to evaluate limits. In the previous, I made a video where I evaluated other kinds of limits. You can watch it. right? I hope this helps, and please kindly subscribe to get notification when I post more videos. Thank you.